Hi, so in video 1562 on the main channel we built a Newman motor. We built it because we were interested in the commutation. The idea that we could make a brushless DC motor from two simple components, and to do that we used one coil as a drive coil and the other coil as a trigger coil. Now this idea of trigger coils are quite common actually. They were used in flash cameras for the transformer to build up the battery to the voltage that the flash camera needed, which was 600 volts. And they're very often used in flyback circuits when you're running from DC. In order to run a transformer or a motor, what you need is a varying magnetic field. And of course, if we apply a DC current to a coil, what we get is a permanent magnetic field. So we need to be able to switch it off and on quite rapidly, so that magnetic field will grow and collapse as we switch it off and on. Now when we switch on a DC current into a coil and it has a coil next to it, or it has an iron rod or a ferrite going through it, then we build the magnetic field. And that magnetic field is either in the air or concentrated in the rod. And if we put another coil around that, because the electric current is creating an electromagnet, building up a magnetic field, that magnetic field will then intersect with the secondary current, secondary coil, and induce a current in that secondary coil. Now, we can use that pulse of current to drive a transistor. So if we put that pulse of current on the base of the transistor, when the pulse of current comes in, it turns the transistor on. We connect the first coil to the emitter and the collector of the transistor, then it can flow. So once it flows and builds up the magnetic field, then of course nothing will happen when the magnetic field is static, and so the current going to the base will die, will turn off, and that will collapse the field. And this happens very quickly. Effectively, you're using it as a self-resonant circuit to turn the base off and on, because the secondary coil that you've wound is acting as a switch driven by the first. And remember, these things lag 90 degrees behind on an inductor. And so effectively what this does is act as a self-regulating automatic switch to turn the current off and on in this coil. So this coil is acting at the base to turn that transistor off and on. It's why it's not self-starting. I have to give it a flip to turn it on for a moment to allow the current to flow in here. So this is non-self-starting. It needs a mechanical input to start that process. Once that process is running, then the motor will continue to turn. It will continue to turn in self-resonant mode. So that's how it works. I thought I'd take a moment just to explain that. And as I say, it's a fairly common circuit for lots of self-resonant applications. I hope it made sense. I hope it explained if you were wondering why it worked. Thank you very much for being members, and thank you very much for watching the video.